Welcome to This Explainer. I want you to think about your morning routine for a second. You wake up, maybe you grab a coffee, and almost immediately, you check your phone, right? The world outside your window feels perfectly normal, completely analog. But running just beneath the surface of that quiet morning is this massive, invisible current of code. It's a silent infrastructure, and it's literally driving the direction of humanity in ways we rarely, if ever, actually stop to think about. Which brings us to a deeply fascinating and honestly kind of unsettling question. Who is really making your choices? Because the truth is, somewhere right now, with this hushed, ruthless precision, a machine is deciding things for you. Think about the very last purchase you made online, or the last article you clicked on. Was that genuinely your idea? We desperately want to believe we're the absolute masters of our own destiny, but this vast, unseen digital architecture, it suggests something entirely different.
Look, this isn't science fiction anymore. It is the fundamental reality of our modern world. Algorithms are operating in the shadows right now, dictating the flow of your daily life. They're deciding exactly what information pops up in your newsfeed. They're influencing the products you suddenly feel an intense urge to buy. And perhaps most crucially, they are subtly shaping your political leanings. By building these highly customized echo chambers, these systems can gradually shift what you believe about the world around you, entirely without you noticing the invisible hand guiding the way. So let's get into part 1, the invisible decision makers, and look at our present reality. To really grasp the sheer scale of this, think about the predictive modeling happening on your devices every single day. Every time you swipe or scroll, an algorithm isn't just taking a random guess. No, it is already sifted through literally millions of possibilities. It takes your highly specific behavioral profile, compares it against vast oceans of data, and selects the exact handful of posts most likely to trigger a dopamine hit and keep your eyes glued to that screen. It's this highly curated, mathematically optimized reality, engineered specifically for you in just a fraction of a second. And the shift we're living through is profound when you compare biological choices to digital ones. When a human makes a decision, they need sleep, right? They get fatigued. And importantly, you can sit them down and say, hey, explain your reasoning. But when a major bank processes a mortgage application today, that choice is increasingly made in milliseconds by a neural network. That system never sleeps, it never gets tired, and crucially, it operates as a complete algorithmic black box. Even the developers who coded the thing often can't map out exactly why the model denied your loan. It just decides, and we accept it. Which leads us to part 2, the spark of machine thought. Let's look at the origins of all this. The idea of machines making decisions for humanity didn't just appear out of thin air. We actually have to rewind to the post-war era of the 1950s. Back then, massive computers were mostly used for brute force math, calculating artillery trajectories and things like that. But a small group of visionary scientists and mathematicians started seriously dreaming of thinking machines. They envisioned this radical leap, a future where technology wouldn't just calculate numbers, but could genuinely reason like people do. It was an audacious leap of imagination, but it planted the seed for the reality we're living in today. This whole pursuit was really crystallized by Alan Turing, one of the brilliant founding minds of computer science. In 1950, he proposed what we now know as the Turing test, asking a deceptively simple question: can a machine think? Now, at the time, this was just a philosophical provocation, but that single question sparked a technological arms race spanning 7 decades. It's actually incredibly suspenseful when you stop to realize that a theoretical question posed over 70 years ago is now the defining, active challenge of our everyday lives. The velocity of this technological evolution is just staggering, largely driven by the relentless compounding power of Moore's law. We went from clunky, vacuum tube mainframes that required entire air-conditioned floors to operate to incredibly complex systems running silently right inside the phone in your pocket. The sheer compression of time and space here is unlike literally any other human invention. Think about it. In a single human lifetime, we moved from theoretical academic papers to pervasive pocket-sized supercomputers. By the time we hit the 1980s, the conceptual had become practical, and things started getting quietly serious. We saw the introduction of expert systems, like Mycin, which was an early AI designed to diagnose severe blood infections. These programs, which were built from complex sets of human rules, were already running behind the scenes. They started making highly specialized judgments in fields like medicine and finance. I mean, just try to imagine how weird it must have felt for a human doctor in the 80s to cross-reference their diagnosis with some beige plastic box sitting on a desk. But the thing is, very few people outside of specialized research labs or enterprise computing even knew these early expert systems existed. It wasn't really a deliberate cover-up or anything. The tech was just incredibly niche and required massive, expensive hardware. But looking back at those quiet labs, we can absolutely see the first clues. They provided the earliest concrete evidence that true authoritative decision-making power could be completely delegated to code. It was the quiet, almost invisible creeping beginning of a global revolution. All right, moving into part 3, faster than human thought. Let's talk about the escalation. See, it's no longer just about what machines can decide. It's about the terrifying speed at which they execute those decisions. Consider a single millisecond. It's a completely imperceptible slice of time. Yet today, automated high-frequency trading systems execute critical global stock market decisions in fractions of that millisecond. The arms race for speed actually became so intense that financial firms literally spent hundreds of millions of dollars to bore physical tunnels straight through mountains. Why? Just to lay fiber optic cables that would shave a single microsecond off their trading times. Crazy, right? The contrast between our biological limits and this silicon world is just stark. We're slow biological creatures. A human eye blinking or a nerve signal physically traveling from your fingertip to your brain, that feels instantaneous to us. But in the digital realm, it's an eternity. These algorithmic systems are moving billions of dollars completely friction-free. While our brains are still biologically processing that a moment has even occurred, the machine has already analyzed global data streams, executed the trade, and entirely reshaped the market. And the consequence of unleashing that kind of speed is immense. And honestly, sometimes wildly volatile. In mere moments, these high-frequency algorithms can trigger massive market swings. A perfect example is the 2010 flash crash. Roughly $1 trillion in market value simply vanished, and then reappeared in a matter of minutes, driven almost entirely by algorithms rapidly reacting to one another. Billions of dollars shift globally before a human trader on the floor is even aware that a cascade has started. Which brings us to our final section, part 4, who is truly in control, the haunting reality. The absolutely crucial takeaway from our investigation today is that machines are already vastly outthinking us in sheer speed and complex pattern recognition. And this forces us to step back and look at the macro picture. We are living in a world heavily dictated by unexplainable AI and black box models that operate well beyond the limits of human cognition. It's not just about an individual loan anymore, guys. It is our entire global infrastructure running on interwoven logic that we can no longer easily reverse engineer or even fully comprehend. We've traced an incredible arc in this explainer. From Alan Turing sitting in a room in 1950 asking if a machine could think, to mountain-piercing fiber optic cables and sub-millisecond global markets that operate entirely in the dark. Slowing down completely, I want to leave you with this final, haunting question to ponder long after we wrap up here. With algorithms quietly deciding our news, our finances, and maneuvering our global infrastructure faster than human thought, are we still the ones truly in control? Welcome back to The Explainer. Today we're diving into the absolute mystery behind neural networks. You know, it's wild to think about, but the most crucial technological turning point of our lives, it didn't happen with some flashy global press conference. Nope. It happened quietly, tucked away inside research labs, way before any of us even noticed a shift. So let's track exactly how we went from those quiet labs to the reality we're living in right now. Think about this for a second. What actually happens when we build a mind we can no longer completely understand? I mean, it sounds straight out of a sci-fi movie, right? But as you'll see, this is a very real technological detective story that we're right in the middle of. We're going to look at the data, trace the timeline, and figure out exactly how this happened. Okay, let's dive into this. Section 1, the deep learning spark. So the year is 2012. This marks the exact moment a massive breakthrough hit the scene in a specific field called deep learning. Basically, researchers built computer systems that could suddenly recognize images with a, frankly, startling level of accuracy. And we aren't just talking about some minor tweak or slight improvement here. We're talking about systems actually beating human performance on certain narrow visual tasks. This wasn't just a fun little technical curiosity for academics to chat about. This 2012 breakthrough was the literal spark that ignited the entire modern era of intelligent systems. Which brings us to Section 2, teaching a digital mind. To really grasp why 2012 was such a massive paradigm shift, we've got to look at the old way versus the new way. For decades, traditional programming relied on these super rigid, handwritten rules. A human programmer would literally sit down and meticulously type out every single logical step a computer needed to take. If X happens, then do Y. But this modern era, it doesn't rely on those rigid rules. Instead, these new systems learn by being fed just staggering amounts of data. We're talking millions upon millions of examples, letting the system figure out the patterns all by itself. And that brings us to the core engine making all this possible: neural networks. Simply put, these are mathematical processes inspired loosely by the neurons in your own brain. The way it works is brilliant, but conceptually, kind of simple. As these networks consume more data, they adjust themselves. The more data they eat, the better their predictions get. So the absolute key takeaway here is that we completely moved away from manually programming a machine and moved towards something that feels a lot more like teaching a mind. You give it examples and it just learns.
All right, moving on to Section 3, AI in the wild.
So now we're in the mid-2010s, right? And this incredible lab tech quickly and almost invisibly starts seeping right into our daily routines. Honestly, it happened so fast, we kind of took it for granted. Voice assistants suddenly started actually understanding spoken language, becoming totally normal fixtures in our homes. Meanwhile, the recommendation algorithms on your favorite streaming platforms started predicting exactly what you'd want to watch next, sometimes with a really unsettling accuracy. And it definitely wasn't just entertainment. Hospitals started using these neural networks to analyze medical scans. They realized these systems could detect certain cancers just as accurately as highly trained human radiologists. In some instances, the AI was catching tiny, subtle patterns that the human eye completely missed. So this tech was no longer just a lab experiment. It was out in the wild, saving lives and completely curating our day-to-day experiences. But then, the stakes escalated dramatically. Section 4, the AlphaGo breakthrough. The year is now 2016. Researchers had designed a computer program called AlphaGo specifically to play the ancient strategy game Go. And in 2016, this program sat down and actually defeated one of the world's absolute top human players.
Now, to fully get why this was so mind-blowing, you have to look at what the experts were saying right before this match. Go is an incredibly complex game, way more complex than chess when you look at the possible board configurations. Because of that insane complexity, experts across the board had confidently predicted that machines were still decades away from mastering it. Literally, no one thought we'd see a machine win at Go for a very long time.
But here's the thing, AlphaGo didn't just win. It didn't just follow known, historically successful strategies that we fed it. The system actually invented entirely new strategies. It executed moves that professional players had literally never considered in centuries of playing the game. Let that sink in. This was a profound moment. It was the exact moment where machines stopped merely following the rules we taught them and began showing a genuine form of digital creativity. Of course, this immense power didn't come without serious consequences. Section 5, the data privacy backlash. Fast forward just a couple of years to 2018. This was the year the public was really shocked by some major revelations regarding data. Remember, these neural networks run on staggering amounts of data to function. And in 2018, it became crystal clear exactly how that data was being acquired and deployed. We all learned how personal data had been harvested on a massive scale and then used to influence political campaigns.
This sparked an absolute firestorm of urgent societal questions. I mean, did people even know their data was being taken? What rights do we actually have over our own digital footprint? And how easily can these highly predictive systems be turned around to predict and influence our own behavior? The public suddenly woke up to the massive, insatiable data hunger that's required to run these neural networks.
And this brilliantly illustrates how almost overnight, the entire global conversation shifted. We shifted away from asking the purely technical question, what can these systems do, to grappling with a deeply ethical one, what should they be allowed to do? Let's just take a quick breath and look at this timeline to summarize how incredibly fast all of this progressed. In 2012, we had the deep learning spark in the lab. By the mid-2010s, this tech quietly integrated into our streaming services and hospitals. In 2016, we saw shocking digital creativity with AlphaGo. And by 2018, we had a massive societal paradigm shift and privacy backlash. We literally went from a narrow lab experiment to a total reshaping of society in less than a single decade. It's wild.
Which brings us to the ultimate, undeniable paradox we're facing today. Section 6. The black box mystery.
Today, these systems have scaled up to an unbelievable degree. They're writing coherent text, generating totally photorealistic images from scratch, analyzing incredibly dense legal documents, and even actively assisting in brand new scientific discoveries. They're operating at these incredibly high cognitive levels across almost every domain you can possibly think of.
But here is the core mystery, and it is a sobering one. Humanity is building tools whose inner workings are becoming harder and harder to fully explain, even to their own creators. Because these neural networks teach themselves by finding patterns in millions of data points, the exact logic they use to arrive at a brilliant answer is often hidden inside this mathematical black box. The programmers know for a fact the system works, but they can't always explain exactly how it reached its conclusion. And that uncertainty completely sets the stage for the most important chapter of all. If creators can't fully explain the inner workings of their own tools, what happens in the next chapter? We've unleashed a digital mind that learns on its own, solves problems in ways we never taught it, and operates in a way we can't fully map out. It's absolutely the greatest technological marvel of our time, and perhaps our greatest mystery. I hope this explainer helped you visualize just how we got here. Thanks so much for joining me today, and I'll catch you in the next one.
Hey everyone, and welcome to The Explainer. Today, we're diving into something that literally affects every single one of us, every single day. We're talking about the invisible algorithms governing our modern world. But we're not just going to geek out on the math or the code here. We're looking at a deeply human focus, how these massive automated systems are actually magnified mirrors of ourselves. Basically, how they reflect our human values right back at us.
What was once experimental is now infrastructure. I mean, let that really sink in for a second. We used to talk about AI and complex algorithms like they were this far-off sci-fi future, right? Whiteboard concepts, beta tests, these isolated little experiments locked away in tech labs. Well, not anymore. This isn't a future concept. It is the literal fabric of our daily existence. It's the infrastructure of our civilization right now.
So, to really understand how this happened, and more importantly, what it means for us, we're going to break this down into 4 distinct chapters. 1. The invisible infrastructure. 2. A double-edged power. 3. The race for oversight. And 4. Mirrors of human intention. All right, let's jump right in.
Chapter 1, the invisible infrastructure. From experiment to daily life.
When we say infrastructure, we mean these systems are woven into pretty much every corner of modern life.
Think about that package you just ordered. Behind the scenes, logistics platforms aren't just tracking ships anymore. They're analyzing global weather patterns, port strikes, and literally years of historical supply chain data to autonomously reroute cargo weeks before a bottleneck even happens. Crazy, right? And in healthcare, it's just as prevalent. Hospitals are deploying these predictive models that monitor tiny, minute variations in a patient's blood pressure and temperature. They can effectively predict conditions like sepsis up to 12 hours before human doctors can even visibly detect the symptoms. Or think about the traffic you sat in this morning. Major cities are using dynamic systems that process live camera feeds to adjust traffic light intervals second by second. It seamlessly reduces idle time and cuts emissions. It's omnipresent. It is working all around you, making millions of micro decisions while you just go about your day. Which brings us to Chapter 2, a double-edged power, the tension between good and bad.
Now, with this immense, omnipresent power comes a very real, very complex tension. And these controversies, they aren't hypothetical, and they are completely unresolved. Take hidden bias, for example. There was this highly publicized case where a major tech company built an experimental hiring tool to filter resumes. Sounds great in theory, but because the model was trained on 10 years of historical hiring data from a male-dominated industry, the algorithm actually taught itself to penalize resumes that included the word women's. It wasn't explicitly programmed to be biased, it just mirrored the historical data it was fed. Then, of course, there's the wave of job displacement. We're moving way past just blue-collar automation now into severe disruption of white-collar work. Generative tools can instantly process legal research, write code, perform complex data analysis. It's threatening entirely new sectors of the economy. But perhaps the most difficult piece of this whole puzzle is the massive challenge of accountability. Think about it. If an AI-driven medical diagnostic tool recommends the wrong treatment to a patient, who exactly is legally responsible? Is it the doctor who trusted the machine, the hospital that bought the software, or the engineer who wrote the code? These are active, fierce debates happening impartially right now in courtrooms and parliaments all over the world.
But we've got to immediately pivot to the other side of the blade here, because the exact same technology causing those active debates is simultaneously fueling some absolutely extraordinary breakthroughs. Take drug discovery. A system called AlphaFold recently solved this massive, grand challenge in biology that had stumped scientists for 50 years, predicting the 3D structure of proteins. It managed to map hundreds of millions of proteins in just a matter of months. That's a feat that would have literally taken human researchers millennia. We're also seeing systems that process satellite imagery and seismic data to predict the path of wildfires or the severity of earthquakes milliseconds faster. They can automatically trigger train brakes or issue evacuation orders that actually save lives. And in the fight against climate change, scientists are leaning on these algorithms to simulate incredibly complex atmospheric variables. They're pinpointing microclimates so farmers know exactly when and where to plant drought-resistant crops. So the story of this technology is absolutely not just one of danger. It's a story of immense, truly double-edged power.
So Chapter 3, the race for oversight, the gap between policy and technology.
Governments and researchers are absolutely racing to keep pace with these systems right now. There are some major global regulatory efforts currently underway. For instance, the European Union has put forward its landmark AI Act, which takes a really fascinating approach by categorizing systems by risk level. So under this act, unacceptable risk systems like government social scoring are entirely banned. High-risk systems, like those used in law enforcement or hiring, face strict transparency audits. Meanwhile, minimal-risk systems, like your standard email spam filter, they're left largely alone. It's a massive attempt to set a global standard. Simultaneously, there are ongoing high-level discussions happening at the United Nations. They're aiming to establish a global advisory body to ensure that developing nations aren't left out of the conversation. Ultimately, what this reflects is a vital, shared global recognition. Before these powerful systems are entirely entrusted with decisions affecting millions of lives, they desperately need structured oversight.
But here's the fundamental friction we face right now. Regulation moves at the speed of committees. It requires debate, consensus, drafts, and endless revisions. Meanwhile, technology moves at the speed of code. It's instantly updated, endlessly iterating, and just moving so much faster than our traditional human systems can comfortably track.
And that brings us to our final section, Chapter 4, Mirrors of Human Intention, the Truth Behind the Code. Ultimately, we're left with a pretty simple reality. The tools human beings build always reflect human intention, for better or worse. This is perhaps the greatest lesson from this entire journey into automated infrastructure. There is no such thing as a truly neutral tool. Every single line of code, every dataset, every predictive model, it all carries the fingerprint of the people who designed it.
Machines don't choose their goals. We do. The systems shaping our world right now, no matter how complex or autonomous they might seem, they aren't just isolated brains thinking in a void. They are massive statistical engines trained on human output. When we feed an algorithm the entire internet, well, we feed it all of our brilliance, our prejudices, our creativity, and our flaws. The training data acts like a historical mirror of human behavior. These systems are simply mirroring our own values and ambitions, and then amplifying them at a scale that was literally never before possible. The automation isn't creating the intention, it's just executing ours.
So the question is no longer whether powerful systems will shape our future, because as we've just seen, they already do. The real question we have to ask ourselves is this: will humanity shape them with wisdom before they shape us in ways we never intended?